Hi everyone, this is lesson 11 and today we're going to talk about active buzzers. In this lesson, you will learn how to generate a sound with an active buzzer. So let's first introduce the component. So buzzer introduction. Electronic buzzers are DC powered and equipped with an integrated circuit. They are widely used in computers, printers, photocopiers, alarms, electronic toys, automotive electric devices, telephones, timers, and other electronic products for voice devices. Buzzers can be categorized as active and passive ones. Turn the pins of two buzzers face up, and the one with a green circuit board is a passive buzzer, while the other enclosed with black tape is an active one. So now we can demonstrate this. Here is the one enclosed with black tape, so this should be an active one, like this. You can see it's kind of glossy as well. Alright, and then this one, there is green circuitry at the bottom, so this means that this is a passive buzzer. And then this one, you can see it's polarized, it has a positive. And this one, I haven't ripped off the cover yet, but it also shows that this side is positive, so both buzzers are polarized. And then today we're only going to talk about the active buzzer, which is this one. Oh wait, sorry, wrong one. Which is this one right here, covered in black, like this. So we're only going to use this one today for demonstration. Alright, so that's one of the difference, the bottom. The other difference between the two is that an active buzzer has a built-in oscillating source, so it will generate a sound when electrified. So if it has enough power, it will always create a sound. On the other hand, a passive buzzer does not have such a source, so it will not tweet if DC signals are used. Instead, you need to use square waves, whose frequency is between 2K and 5K, so 2000 and 5000, to drive it and make it create sounds. The active buzzer is often more expensive than the passive one because of multiple built-in oscillating circuits. Alright, so this is a basic introduction to the component for buzzers, and we're going to build a little circuit. The circuit is really simple, so like this, very simple. This is the Uno board, and then positive end is the digital 12, goes through the positive end of the buzzer, for active buzzer in this case, and then goes negative to the ground. So this is a very simple circuit, so let's build it quickly. Alright, in here, so we're using the active, this one, and then let's put it on. let's say right about here, and then we get a positive wire like this, put it here, and then let's connect it to number 12. It doesn't really matter what pin you're using, but 12, we'll go with that today. And then connect the other end into the ground like so, and then make sure you're connecting them onto the right one. Alright, so this is all the circuits that we need. Connect one end to the buzzer and the other to the Uno board like this. Alright, and then now we can set up some code. So we need to define our pin, constant integer buzzer. We used pin number 12, so 12, and then we can set up the mode. So buzzer is output, so buzzer is pin number 12, and then we can set the buzzer to high, which should be done in the loop, so it constantly, or we can also put it in the setup if we want, since we're not changing anything yet. Digital write buzzer high like this. Alright, now we can connect our board, and then we can run this. So now, as you can hear, there is the high frequency pitch ringing noise, which is produced through the buzzer. Alright, now let's turn it off. Alright, and we can also change our the frequency somewhat if we just make a loop in the loop section, and then we use delay, and let's say 10 seconds, so, or this is 10 milliseconds, right? And then turn it off for 10 milliseconds, and then turn it back on for 10 milliseconds, turn it off for 10 milliseconds, and this keeps on looping. And so it will sound a little weirder, but the frequency should change a little. So let's try this. This is the one from before. Now let's upload our current code. Right, this should not be capital. Alright, now this should work. Yeah, so as you can see, the sound is a little different now. Alright, and we can make the delay longer like this. So now there should be visible pauses in between the turning on and turning off. This sounds more like an alarm or something like that. And then we can make this even longer, let's say a whole second. Now this sounds like maybe another type of alarm or something. Alright, so this is about all that you need to know for octave buzzers. They are quite simple. Alright, let's copy our code. Let's unplug our Uno board. Alright, so this is the code. This is all the code there is. And then let's create a conclusion section for our thing. So advantages. This does not need complex circuitry, and all specifics can be handled with our code or software. So as you can see, the circuit really is not that complex. Only 2 wires are needed to connect the digital 12 pin to the positive end and connect the ground and negative end of the buzzer. So this is all that we need for the circuitry, so not complex at all. and all these specifics can be handled with our code. So these, you can make this longer, shorter, or however you like, and it can be handled like that, which is pretty good. And there's a negative, so advantage, disadvantage, active buzzer can only make a single frequency pitch, which does not sound musical and cannot create music. Alright, so active buzzers, that's what we were talking about today. Active buzzers, they can only create a single frequency, and this doesn't sound musical at all, and you can't create music, as opposed to our passive buzzer, which we'll talk about in lesson 13, I believe, which we can create songs, and it's a lot more customizable in our code. Again, the circuit probably won't be that complex either. And then lastly, let's note the active buzzer has positive polarity and negative polarity. Please don't forget this and put it on backwards. That would be detrimental. Yeah, and then you can simply see which side is positive through, for example, this is on this one, you can see a positive sign here, positive here, and that means this side is positive. So this pin here is positive, and then this one, since there's still a tag on it, you can see that this side is positive. Make sure to not forget that there's polarity. Alright, and then for the homework, I want you guys to recreate the experiment and film the buzzer for 5 seconds while it is buzzing. So it's alright if you guys just write one here. So buzzer high like this, and then you guys don't need to have anything in the loop, and just keep it like this, film it for 5 seconds and upload it. Alright, that's it for this video. Thank you for watching, and see you next lesson.